Friends, welcome in the world of chemistry. So, welcome in my YouTube channel, and today we are going to discuss one of the important concept, that is electronic displacement in covalent bond. So, this is the most important concept in organic chemistry, particularly those who are preparing for NEET examination, for JEE examination, and those who want to learn the chemistry, organic chemistry particularly. So this is very important and basic concept, that is electronic displacement in covalent bond. So first, what is meaning of electronic displacement? What is electronic displacement in covalent bond? So meaning of electronic displacement is shifting or the movement of electron, movement or shifting, movement or shifting of electron within the molecule, within the molecule, affecting reactivity and stability of molecule, Okay, so this is the meaning of electronic displacement in covalent bond. So electronic displacement, what is meaning of displacement? Displacement means shifting or movement from one atom to another atom, from one bond to another bond to atom. So this is known as electronic displacement. Movement or shifting of electron within the molecule, affecting the reactivity and the stability of molecule. Okay, so this movement of electron, particularly this all the organic chemistry, the mechanisms, they are based on the movement, or we can say the shifting of electron. Okay, so electronic displacement in covalent bond, you know basic concept. What is a covalent bond? It is formed by sharing of electron. And what is bond? First we try to understand what is bond. Bond means the force of attraction, which holds two atoms or two chemical species together is called as bond. Okay, so electronic displacement, that is a movement or shifting of electron within the molecule, and depending upon this shifting or the movement of electron, the molecule's reactivity and stability is depend on this basic concept or this electron shifting. Okay, now the types of electron shifting. Okay, there are different types of electron displacement. Electron displacement in covalent bond. Okay, mainly electronic displacement, generally they are classified into two types. First type of electronic displacement is called as polarization, and another type of displacement is called as polarizability. Okay, so polarization, it is a permanent electron shifting or permanent electron transfer, where polarizability, it is a temporary. Polarization, it is a permanent electron shifting. This effect is permanent, and polarizability, it is a temporary effect. Okay, polarizations, again it is divided into inductive effect. Type of polarization is inductive effect, which is permanent effect and very important. We call it as I effect, or this inductive effect is also called as transmission effect. Inductive effect is also called as transmission effect, because inductive effect transferred through the sigma bond from one atom to another atom. First is inductive effect, second is mesomeric effect. It is also known as resonance, but there is a slight difference between mesomeric effect and resonance, but nearly this concept is same. Okay, the third one is hyperconjugation. Next is hyperconjugation. This is again the important concept. Hyperconjugation, this is permanent effect. Okay, so polarization effects, inductive effect, mesomeric effect, hyperconjugation effect. Mesomeric effect is called as M effect or R effect. Hyperconjugation is called as H effect, and the last one is a field effect. Or EF effect. Okay, So these are the permanent effects in electron transfer. The next one is the polarizability. It is a temporary effect. Polarizability again divided into two types, that is electromeric effect. Electromeric effect, we call it as E effect, and the another is inductometric effect. Inductometric effect. So these effects are the temporary effects, inductometric I effect. Okay, these are the main two types of electron displacement. First is a polarization, this is a permanent. Polarizability, this is a temporary effect. And the polarization again divided into this sub effects, that is inductive effect, okay, by means of inductive effect, mesomeric effect, hyperconjugation, field effect. And polarizability is a temporary effect. There are two types of temporary effect, electromeric effect and inductomeric effect. Now we will see one by one. Okay, so first we will see what is meaning of inductive effect. Okay, just wait. First we will see what is meaning of inductive effect. Okay, so inductive effect, it is a permanent effect. Okay, first we will see what is meaning of inductive effect. So inductive effect, it is called as I effect, or it is also called as or it is known as a transmission effect, because there is a transmission of electrons through the sigma bond. Inductive effect or transmission effect, it is called as I effect. So what is the inductive effect? It is a permanent shifting of electron or lone pair of electron, okay, or we can say permanent shifting of electron towards more electronegative atom. Permanent shifting of electron towards more electronegative atom. Permanent shifting of electron towards more electronegative atom. So this, in inductive effect, shifting is possible because of difference in the electronegativity. Let us take the simple example. This is the carbon chain, and let us consider this X. X may be halogen. Okay, let us imagine that is halogen or electron withdrawing atom. So this electron withdrawing atom, it withdraw electron, therefore it get a slight negative charge, partial negative charge, whereas this carbon one gets delta positive, okay, positive charge, and another one get delta plus plus, means positive charge is decreased here, and again delta plus plus plus. Okay, or we can say delta delta plus, here is delta delta plus. Okay, delta means negligible charge. Okay, actually this is a the example, and you can say this how in inductive effect electron shifted towards more electronegative atom. So this X is more electronegative, therefore it withdraw the electron, and this effect is particularly transferred through sigma bond, and generally it is observed in saturated compounds, these compounds containing carbon-carbon single bond. Okay, so this happens, there is a difference, this difference delta plus and here delta minus, this difference is only because of the difference in electronegativity. There is a difference in electronegativity, therefore electronegative atom withdraws electron towards itself. So what is electronegativity? We try to understand the basic concept electronegativity. It is electronegativity, it is a capacity or tendency of atom to withdraw electron towards itself. It is called as electronegativity, and this X is more electronegative as compared to carbon, therefore it try to withdraw this bonding electron towards itself, hence it get partial negative charge, while carbons get positive charge, and this effect after 2 carbon, this effects get diminished. Okay, there is a loss of effect after 2 carbons. Okay, and what are the applications, what are the types? Okay, basic types of inductive effect. There are 2 types of inductive effect, plus I effect and minus I effect. Plus I effect means electron releasing effect, and minus I effect means electron withdrawing effect. Okay, these are the 2 types of inductive effect. Plus I effect, example of the groups which show the plus I effect, that is, you know, the alkyl groups are, or we can say the methyl group, C2H5 ethyl group, or C3H7 propyl groups. These groups shows the plus I effect. They try to release the electron. Okay, and minus I effect is shown by the some compounds like some functional groups like COOH, then NO2. Okay, then cyanide group, they show the minus I effect. And what is the application of this inductive effect? There is a one important application, that is the acidity and basicity of the compounds is decided by this effect. Acidity and basicity of compound decided by this effect, as well as the stability of carbocations and stability of carbanions can be described with the help of this effect. Let us take the one simple example how the stability of carbocation depends upon this effect. Let us take the example, this tertiary carbocation. Then another example, these carbons are there, tertiary carbocation. This is secondary carbocation, and here this one, it is a primary carbocation, and the last one is the methyl group, CS3. Okay, so here which is the more stable? So this tertiary carbocation is more stable as compared to secondary. Then secondary is more stable than primary, and then methyl group. So this carbocation, tertiary carbocation is more stable because of this one, because of this I effect. Okay, this is inductive effect, because of this type of shifting of electrons stabilizes this carbocation. This is the application of inductive effects. So this is all about the inductive effect. So actually inductive effect is a transfer through the sigma bond. You can see here, means it is present in saturated compounds only. Okay, so it is a permanent effect, permanent shifting of electron towards more electronegative atom, and this shifting takes place whenever there is any atom. This shifting is possible only because of if there is a difference in the electronegativity of two atoms, then this effect will be there. Okay, so this is all about the inductive effect. The next effect we will see the mesomeric effect, or also called as a resonance. Okay, but there is a slight difference. Okay, actually both resonance is a broader concept as compared to mesomeric effect. Second is mesomeric effect. Mesomeric effect, or it is called as Young effect. Young effect, or it is also called as, or we can say it as a resonance. Resonance R effect. Okay, so what is the resonance or mesomeric effect? Delocalization of electron. Okay, mesomerism, it is delocalization of electron, lone pair of electron actually, delocalization of lone pair of electron or pi electrons, delocalization of lone pair of electron or pi electron to adjacent atom or within a conjugated system. Conjugated system is system which contain alternate double single bond, that is called as the conjugated system. So here the most important thing is pi bonds. Pi bonds will be shifted. Electrons from the pi bonds will be delocalized, or we can say the lone pair of electron can be delocalized from the atom. So let us take the one example of this, and there are many applications of resonance. So resonance is a very basic concept to understand the organic chemistry. Resonance means simply delocalization of electron or shifting of electron or delocalization of pi electron is called as resonance, and this is important to decide the acidity and basicity of compound. And also most important thing, this effect is responsible for the reactivity of compound in the organic reaction. You know, just I'll take one example of acidity. Phenol is more acidic than alcohol. Why phenol is more acidic than alcohol? Because phenoxide ion is stabilized by resonance. So let us take the example of resonance in the phenoxide ion. Okay, so this is phenoxide ion. This contains oxygen having a negative charge. How the resonance will take place? This shifts here. Okay, this bond again shifts here at this position, and we can draw the resonance structure. the different structures, equivalent structures, okay, they are known as resonating structures or the canonical forms. Okay, what will happen? Next step is C double bond O here. Okay, this electron is shifted at this position, therefore here is a negative charge. Okay, so in this case of resonance, there is a complete transfer of electron takes place. Okay, this is not a partial transfer, this is the complete transfer of electron. Okay, then next step, here you can see this electron move to this position. Okay, again shifting up next. Okay, C double bond O as it is, this is as it is, C double bond O, this bond shift here, this bond move to this position, here negative charge. Okay, this is the another canonical structure or resonating structure. The next structure, you can see what happened, this electron transport to this position and this bond shift to next position. Okay, here you can see shifting at this position, C double bond O as it is. Okay, and here this is the last step. What will happen? Sorry, electron shift here. Okay. Negative charge. Okay, this bond formation here is shifting of negative charge. Next, this will shift here and this will shift here. Okay, and finally we will get this phenoxide ion again. Here is a negative charge on phenoxide ion. This bond shifts here, remaining bond as it is. That's why, okay, because phenoxide ions having different resonance structure, therefore it is more stabilized by resonance, hence it is acidic as compared to alcohol. This is the reason behind this. Okay, this is about the mesomeric effect or resonance effect. Okay, and the next concept we will see, that is hyperconjugation. Okay, what is the meaning of hyperconjugation? Okay, so this mesomeric effect or resonance effect we have seen already. This is a permanent effect. Okay, the next third effect, it is known as hyperconjugation. Hyperconjugation, it is also known as non-bonded resonance. It is also called as non-bonded resonance, or it is also called as Baker-Nathan effect. Baker-Nathan effect. Okay, hyperconjugation, it is non-bonded resonance, particularly it is seen in alkenes. So what is hyperconjugation actually? The interaction of sigma electrons, okay, or interaction of sigma bond or electrons with pi bond or pi electrons. Okay, this is known as hyperconjugation. Okay, so interaction of sigma bond with interaction with the pi bond. Okay, let us take the one example of this one alkene. Here you can see if this compound. Okay, so here is hydrogen. Okay, let us take this example. This is ethyl carbocation. Okay, if the condition is like this is ethyl carbocation. This is ethyl carbocation. So what happened here? Here is a positive charge. Therefore, this carbon is electron deficient. Therefore, this electron transfer here at this position, and we will get the structure. We will get the structure like this one. Hydrogen remain as it is, and here is a double bond. This bond, sigma bond actually, sigma bond transferred over here. Okay, and here is double bond, CH. And what happened with this remaining, this one hydrogen? This hydrogen is here only, having H plus charge. Okay, but it is not bonded. Therefore, it is called as non-bonded resonance. Okay, therefore it is called as non-bonded resonance. So actually, the MTP orbital, interaction of sigma bond with pi bond, or we can say with MTP orbital. MTP orbital. Okay, so there is interaction of this sigma electron with MTP orbital. Interaction takes place with MTP orbital. Okay, and this type of interaction, it is called as hyperconjugation. It is called as non-bonded resonance. It is also known as Baker-Nathan effect when we compared inductive effect, hyperconjugation and resonance. The most strong is the resonance, then hyperconjugation, and the last one is inductive effect. Okay, so this is permanent effect. I hope you will understand this concept. And next we will see the another, that is the polarizability effects. Polarizability or temporary effects. Already we have seen the classification. In that electromeric effect, okay, electromeric effect are called as E effect. Okay, so what is E effect? E effect is a shifting of electron due to electronegativity difference, shifting of electron from one atom to another atom, from one atom to pi bond, or from pi bond to adjacent atom. I will explain you this. Consider this is Y is atom. Here is a double bond, here is single bond. If lone pair of electron is present here, it can shift here, or we can say, let us take this is Y, or there may be chances of transfer of this pi electrons on this atom. Okay, so this type of transfer takes place in this electromeric effect. There are two types of electromeric effect. One is a plus I effect, electron donating effect, plus E effect, minus E effect, electron accepting effect. Okay, and this effect actually observed in multiple bonds. Okay, shifting of electron from atom to pi bond, or from pi bond to adjacent atom, or from one bond to another bond in multiple bonds. Okay, this takes place in multiple bonds. Whereas inductomeric effect, another last effect, inductomeric effect. So inductomeric effect, it is called as IN effect, in effect. Inductomeric effect, it is actually, it is same as to electromeric effect, but what is the main difference? This takes place in the single bond. This takes place in the sigma bond. Here is a transfer of electrons, and the most important thing is these two effects. This effect is only shown by the atom or molecule only in presence of. This effect is shown by the atom or the molecule only in presence of attacking reagent. This is the most important thing. You have to always remember this effect. When we remove the attacking agent, there is no effect at all, or we can say there is a removal of effect. Okay, so when we remove attacking agent, then no effect. So the compulsory condition here, the reagent must be present. Under the influence of attacking reagent only, this effect is possible. So let us take the example. Okay, here in electromeric effect, C double bond, you can see this bond. Okay, if attacking reagent is there, let us consider H plus. Okay, so in multiple bond, this effect is present, and this effect is only effective. Here you can see this one will get a negative charge, this one will get a positive charge. So attack takes place at this position, and we will get the structure like the hydrogen is bonded here. There is single bond, here is a plus charge. Okay, so this effect, this is the attacking reagent. Let us consider this hydrogen H plus is the electrophile. Okay, so this electromeric effect and inductomeric effect is only shown by the compounds in presence of attacking reagent, and this electromeric effect is observed in the multiple bonds. This is the important, you have to remember, particularly for NEET exam or JEE exams. This type of question may be asked. This is only effective in, generally it is observed in multiple bonds, and this inductomeric effect is observed in sigma bond. So this is all about the electronic displacement in covalent bonds. Okay, so there's 5 effects. Permanent effects include the inductive effect, then mesomeric effect or resonance effect, hyperconjugation. These 3 are the permanent effects. And the temporary effects, polarizability effects, electromeric effect and inductometric effect, they are temporary effects. Okay, actually the whole organic chemistry is based on these basic concepts. Okay, so thank you for listening. Thank you once again.